All right, this lecture is from chapter 2 of the Tunic book about cheese making, and we're going to talk about curds and whey. And it's not letting me advance. There we go. So the objectives are to list and describe what happens during the 12 steps of cheese making. Talk about the differences between pasteurization and homogenization, and talk about 5 common classes of cheese and 1 variety of each. We will also talk about yield. So the first thing that we need to do is define the following terms, and you will find that in the reading section of chapter 2, but you should know what these terms mean. Standardization, yield, rennet, ripen, and starter culture. So by the end of the lecture, you should be able to tell us what that is. So basically with cheese making, we've talked before about how every different type of cheese is a little bit of a different recipe, as far as, like we've talked about, it's all kind of basically the same ingredients, but the recipe is a little different as far as the type of starter bacteria, how it's cut, how it's aged, how it's ripened. So the recipe is actually called a make sheet. And in your reading material, you'll see an example of a make sheet. Usually they practice recipes over and over till they get it just like how they want it, as far as protein content, moisture, etc. So it includes the steps involved, the timing. How long does the milk sit in the table before they add the starter culture? How long do they leave the starter cultures on? How long do they leave it drain? It will also have the ingredients. So some cheese, like we talked about, had, I mean, it all had milk, but some had starter cultures. Some had starter cultures and rennet. Some had starter cultures, rennet, and netto. Sometimes there's other ingredients. So what's an example of another type of cheese with other ingredients? What did we try that was more than just milk, enzymes, salt, and starter cultures? And then blueberry goat cheese. So they actually took the cheese and rolled it in fruit to kind of make it appealing to customers. What else was in another ingredient that was in some cheese? What about that blue cheese? What was in that? Mold. What else? Did we have any other kinds of cheese? Yeah, you can have to be, there's only approved colors, so they don't just add like yellow. They add dyes that we'll talk about that further. But what about some of the cheeses that you like to eat on crackers? Like, does anybody ever eat pepper cheese or chipotle cheese? So those are all other ingredients that could be added. So spices or vegetables, etc. So also on the make sheet, they're going to have the test results. So during the production, the lab techs or the cheesemakers are going to take samples and send it to the lab. So they're going to test for things like protein and moisture and salt and things like that while it's in process. So they have the goal result and they have the actual result, so they can see how close they are. So things like the temperatures, the titratable acidity, which is what TA is, and we'll talk about that in our next unit. Maybe the pH, the fat, and maybe some moisture. So what this allows, by measuring this stuff in process and comparing it to the make sheet, if they need to adjust it during the make of the product, they can. So that way they're not waiting till the end. What happens if you wait till the end to test your product and it's not right? You have to scrap it. So if you can make adjustments during, then it actually saves the company money and gives them a good product. So here are the basic 12 steps in cheese making. First, we want to standardize the milk. What does that mean exactly? Yes, you want grade A. You can use grade B also for cheese making. Do you guys all understand the difference between grade A and grade B milk? Okay, grade A has a little bit higher standards, and that's the milk that's used for fluid milk. Yep, and grade B, there's not a lot of grade B around anymore, but you can use that for cheese making, or I think they can still use it for chocolate milk, but it's not of as high a quality. So when we talk about standardizing the milk, remember when we talked about cows? What are some differences between cow milk among the breeds? Yep, the amount of butter fat. What else? The taste. Okay, maybe the taste. due to feed. The protein could be different, right? So if I'm making cheese and I get milk from X, Y, and Z farm, and then I get milk from A, B, and C farm, and I don't mix it together, I may have a lot more butter fat in one set of milk. Right, it's not the same, so your cheese may taste different each time. So we want to standardize it. So sometimes they may add cream to it, or they may, add a little protein or whatever, because they want to have it the same. What happens if you buy a product and you're expecting to taste cheddar cheese, and you open the package and it tastes more like blue cheese or something? Are you gonna be, what's that, Matt? You're gonna be very disappointed. And will you be inclined to buy that product again? No. And what are you gonna tell your friends? Right. So they used to say if a customer is unhappy, they will tell 10 people. If they're happy, they might tell one person. But now with social media, how many people are you telling when you post it on the internet, on Facebook or social media? You only have 11 friends? 11. I don't even know. But you might be telling thousands of people, or if somebody shares it, it could go on and on. You could get 1 million views. So we standardize the milk, make sure it's about the same each time we're going to use it for cheese, and then we pasteurize it. Because remember, milk comes in, it's dirty in the intake. So pasteurization then, our goal is to kill any pathogens. That's an important note. We more than likely kill almost all the bacteria, but the goal is to kill pathogens, and you should write that down because it might show up on a test. But Alexis, kill pathogens. Yep, right by the pasteurization step. Do you guys not have the 12 steps? Oh, yeah. So anyway, pathogens, bad bacteria that can make you sick. And also parasites. No. I know. So we want to pasteurize it. In the process, pasteurization kind of denatures some of the vitamins that are naturally present and some of the enzymes. We'll talk about that later. So then after we pasteurize the milk, they run it through the vats and they add starter culture. So what exactly are starter cultures? Bacteria. Right. Because when the bacteria use up the lactose, that big sugar, what happens in the milk? It curds because the bacteria produce what as a byproduct of metabolism of sugar? Let Matt come up with it. What do we use in the ricotta to curd it? Do you remember? We use vinegar, which is a acid or base? Acid. So when the bacteria use up the lactose, they produce an acid. So that's how the cheese starts to curd. Then we add rennet. So the definition of rennet is an enzyme. It can either be animal-based or I think plant-based. And that clips the proteins apart. So when the cheese starts to recurd, it forms it into better curds. So we have to cut the curd and we have to cook it. So we have to keep all that warm. And then we drain the whey. So the whey is that other soluble protein out of the water. And we pile the curds into a pile. They may handle the curds like they may stir them to keep the whey draining. And then add some salt. What does a salt do? Two things. Yeah, salt provides flavor. And what does it do to the bacteria? Slows it down. So then we press it, get all the rest of the whey out, and we either coat it or package it, and we ripen it, which means we let it sit and let the flavors kind of all meld together. So those are the basic cheese making steps. I suggest you put them on flashcards or otherwise learn them. So that might be a good thing to have on your little note card. So then when we talk about yield, that is the amount of cheese we get out from the amount of milk we put in. In general, for cheddar cheese, it's about a 10% yield. So if we have 10 pounds of milk, we get 1 pound of cheese. If we have 100 pounds of milk, we get 10 pounds of cheese, and so on. There's a formula called the Van Slyke formula that's fancy, and it talks about fat and casein content, how much fat you recover, how much casein you lose. It allows for variation depending on types of cheese. So your yield for, do you think your yield for ricotta is the same as your yield for cheddar? Remember we made ricotta? No, why is that? Ricotta has a lot more moisture, so it's going to be a little bit different. So the same with mozzarella. When we had those fresh mozzarella balls, Cameron, what was in the bottom of that container? Lots of juice, lots of liquid left, okay? So when we had the cheddar cheese, Alexis, and we opened up that, was the package dry or not dry? The cheddar cheese was dry. So depending on the type of cheese, your yield may change slightly. And some plants make their own specific formula that they've used for years and years and years, and as long as they keep using it and standardize it, that works for them. So again, cheddar, 10% is the industry standard. Hard and semi-hard cheese, which is, what is an example of a hard cheese? Oh. What? No, Bree's soft. Oh, it was really hard, like a rock when we banged them together. You put it on spaghetti, you grate it up, put on Parmesan and Romano. Those are very hard cheeses. And then cottage cheese is almost 80% water, so your yield is only 15 to 17%. So again, then when we talk about standardization, grade A milk, here's the definition for the difference between grade A and fluid milk. Are you typing those?
No, I'm trying to type something. Don't worry.
Okay. So fluid milk is less than 100,000 bacteria per mil. So the bacteria count is low in the raw milk. Grade B, used for cheese, butter, milk powder. It has to be less than 500,000 bacteria per mil. So in the intake, or the dairy technicians, when they go to the farm, they do bacteria tests on the milk. Most milk is grade A, and we can't use grade B for fluid milk. So again, a key point to handling is we want to get that milk refrigerated as soon as it comes out of the cow, and keep it refrigerated. Anytime milk is allowed to warm to room temperature, bacteria grow like crazy in milk because they love the sugar that's in the milk. There's protein, it's wet, it's moist. So it's a really good medium to grow milk. Again, standardize it. They'll adjust the fat, adjust the protein for a consistent product. On homogenization, so almost all milk is pasteurized before it's used in fluid milk or cheese because we want to get the pathogens out. Again, some people drink raw milk, some people make raw milk cheese, but it's not legal for sale, okay? So homogenization then, what does homogenization deal with? What components of the milk? It does change the fat. Changes the fat of cheese. Remember, fat's in kind of those globules. So we run it through just little tiny holes at a certain pressure. We break up the globules and they reform into smaller ones. They stay suspended in the milk. They don't rise to the top like cream-line milk. So anyway, it changes how the cheese, I guess, melts. It changes how the cheese, I don't want to say tastes really, but it changes the texture a little bit. And it may need to lead to more different flavors. Why does fat rise to the top of the milk? If it's not continuously stirred or not homogenized, remember fat rises to the top of the milk. Why is that? It's lighter than water. Yeah, it's greasier. When we homogenize, that whole fat globule membrane is removed, so the fat forms into smaller droplets. But it may become more volatile, or it may evaporate more or change more, and then cause different changes in flavors or other characteristics. All right, on the pasteurization slide, you need to highlight 161 for 15 seconds, 145 for 30 minutes. Those are numbers that you have to have in your brain forever if you're going to work in the dairy industry. This is the goal, to inactivate milk-borne pathogens. So this is industry standard as far as pasteurization times and temperatures. We don't mess with these, okay? You have to guarantee in your quality management program that your pasteurizer pasteurizes every single drop of milk at 161 degrees for at least 15 seconds. So you'll run tests on the flow of the pasteurizer, you'll run tests on the thermometer, you'll run tests on the chart recording that records the internal thermometer, you'll run tests on the coolant to make sure it gets cooled down, you'll run tests, there's a diverter valve, so if the pressure's wrong or something's wrong with the heat, it'll divert any milk that's not getting pasteurized correctly out of the system so you can repasteurize it, okay? Pasteurization is the key to food safety. It's frequently a critical control point. It's kind of where the buck stops as far as milk food safety. The side effects, again, then some of the enzymes and some of minor proteins are also deactivated, as well as some vitamins. So raw milk cheese, it's sold mostly outside of the US. Yeah, I don't know. It's their thing. We have to hold it 60 days if made inside the US, and that has to be tested before it's released. Okay, so about additives on cheese making. There's not a lot of additives that are legal in the United States. So you can't just color it with yellow food coloring. It has to be colored with these additives listed here. So annatto, A-N-N-A-T-T-O, that makes it a little more yellow. So cheddar by itself is white. They add the annatto and it turns yellow. Again, these are listed in your reading. Titanium hydroxide, I believe, or titanium dioxide. That actually masks color. It reflects light away, so it makes cheese look paler or lighter. Hydrogen or benzoyl peroxide, that'll bleach the color out of cheese. And calcium chloride, which is a salt that helps increase the coagulation and increase the firmness. So those things are all approved additives. Anything else that you want to add in there is not approved necessarily. You can add fruits, veggies, spices, meats, and smokes and other flavors, but you have to have a certificate of guarantee from the place that supplies you that they are food grade or food quality. Does that make sense? Okay, you can't just go out to Joe Farmer's garden, throw his stuff in your cheese. You have to, it has to be certified that it's guaranteed to be free of pathogens. That's different. This is cheese for selling. So again, we've talked a couple different times about the different classes of cheese and the fact that they're made differently. So you can see some listed here. I would refer back to that Schreiber thing. The Schreiber handout is a good one. And here's your reference. So that's the same as that reading material. Just a second here. I'm going to stop the recording.